weather and erosion, and we're going to look at landscape evolution of San Diego County. And this is a spectacular viewpoint for being able to see the landscape of the county. So that's why we're up here, just so that we can see the lay of the land. There is a technical term that goes with this that geologists use. The term is geomorphology. What could that mean? Geo is earth, and morphology is the shape of the land. And so, you know, I can call this the lay of the land, but we are here to make some primary first-order observations about the geomorphology of the San Diego landscape. So the first thing is, like, we are up on a hill, you know, and you could ask yourself, why are these hills here? That's one of the questions we're going to address. Before we do that, though, we're going to scan out across the landscape here, and we're going to take a look at San Diego and how it's laid out. We're going to scoop our eye down on the south, and then we come into San Diego Bay down into the south. We'll take a couple of pictures of this. What is the most striking aspect of the shape of the landscape out there that catches your eye?
Valley.
It's bordered by mountains in the background, and then there's a big flat surface, and into that surface, what do you see? Canyons that are cut into it. This is the main, these are the main shapes that we need to be able to explain in order to understand how this landscape has evolved. And so, let's have some ideas. And we're going to look right here in front of us. That canyon right there that the 52 is in, that is San Clemente Canyon. Now, you can see that the canyon is bordered by that flat surface. What's the history there? What has happened? What is the canyon first, or is the flat landscape first? The flat landscape is first because there's a river that's cut down through it. And what has that river done? It's carved out a canyon for itself. So it's eroded into that. That's one of the primary things that we can see from this. Let's back up for a second and just talk about, this flat area. And you can see Miramar, you can see one of the jets. There goes your taxpayer money. Coming up out of the airport and cutting to the left. That's the Miramar base. You know, it is using this flat surface, you know, for the runway. But it's a very flat. Now, something has made the landscape very flat. Now, what could that be?
Water pressure. Ocean. River.
You guys don't even need me. But the effect of water is gonna do what to a landscape? If I have something that's steep and rubbly, the effect of water and erosion is gonna do what? It's gonna try to reduce it and flatten it, right? And so we could make an assumption that we could test that this has something to do with water here. This geology thing is tough. Why did I say geology is so hard cognitive-wise? What makes geology tough?
It's too long.
It's too long. The things that have shaped this have taken millions of years, and we're only around for a few years. And so it's hard to really get adjusted to the changes that have taken place over the landscape. One of the huge things that happened just up to 10,000 years ago, there were big continental ice sheets covering a major part of North America. And 20,000 years ago, they were even bigger. They were at the actual maximum. At that time, when the ice sheets were huge on top of the continents, what do you know about this sea level? It was lower. And not only was it lower, it was hecka lower. It was almost 120 meters lower. Wait, how many feet is that? Meters. How many feet in a meter? Yeah, about 3, right? So it's almost 400 feet lower. That is way lower. If we were standing here 20,000 years ago, you wouldn't want to be. You'd be all alone. The sea level would be so far back out that way you might not even see the ocean, you know, if it wasn't a clear day. And so one of the things that's associated with glaciation is sea level is not stable. It goes down, and it can also come up. And then the other thing, who's heard about the, you guys know about the Pleistocene glaciation. You probably heard of it, right? During the Pleistocene, who's been to La Brea tar pits? What animals were living 10,000 years ago? The woolly mammoths were living, these giant ground sloths. The saber-toothed tiger, Smilodon, that's the California state fossil. There were an enormous number of big scale mammals that have disappeared from the geologic record over that last 10,000 years. Oh, we call disappearing completely extinction. You know, it's one of the big mysteries in biology, geobiology, why all of these animals have disappeared. Nevertheless, they're gone. So 10,000 years ago. But sea level is coming up and down. But there wasn't just one big glaciation. Did you know that during the Pleistocene? So you heard about it and you knew that it was cold. But it wasn't just cold for a few million years and got warm again. Did you know this one? It turns out that it gets cold and warm and cold and warm, and it's been oscillating back and forth. And so from a geologic perspective, we are still in the Ice Age. It's just that we're in a little warm interglacial period. In terms of the long-term projection of what's happened the last couple million years, we should be expecting to enter into another Ice Age, going back into the cold thing. But in fact, what is everybody telling you to worry about?
Global warming.
Global warming, you know, maybe in the short term global warming is what we're going to, but in the longer term and in terms of the geologic record of this oscillation, you know, cold is what you would think that we would be worried about. Now, remember I said that the sea level was down? But if you go back farther than 10,000 years, if you go back 100,000, 200,000, guess where sea level was? Higher. And I'm going to show you how much higher right now. If you look out past the airport, you see Miramar, see the airport? If you go beyond that, you see a little ridge that sticks up, a low ridge. Can you see it? It's just a couple hundred feet high. It comes up into the edge of Fortuna Mountain right there. You know what? If you all can't get your eye on this, somebody's going to take this picture and they're going to annotate it, and we're going to check it when we get back in the classroom. That little ridge back there marks what?
Sea line.
It marks the edge of the where the ocean was about 700,000 years ago. So if we were standing here 700,000 years ago, the ocean would be extending out this way, and we would be standing on an island in the middle of the water. And now, what's created this flat surface? The water. That high sea level, as it goes in there, remember the waves are always crashing at the same level, and it's just carved this out. Who's driven the Big Sur Highway? Now, when you're on Big Sur Highway, where are the mountains? They're right there. They're right at the coastline. One of the things that makes San Diego so special compared to any other bit of the coastline in all of California is that you have this big, flat mesa embayment right next to the coastline. You don't see that in other places. And this big bite is because there's soft kind of rocks that the ocean has been able to carve into during this high sea level stand. And it's created the San Diego embayment. When we get down to Tourmaline, we're going to be seeing kind of a similar type deal.